Here is a short demo highlighting key features developed in the NGI DAPSI Digital Immunization Passport project. To cover all data portability aspects of an electronic vaccination record, we created 3 data flows to demonstrate solutions for specific administrative and technical challenges. We demonstrate creating a verifiable credential for the booster shot of a tick-borne encephalitis vaccination for the first data flow. From a user perspective, the process starts by establishing a secure connection with the clinic, and the software checking compliance with the clinic's usage policies for sharing data. Following the initial data capture, including information about a previous vaccination, the user sends the vaccination request to the clinic via an encrypted channel. The clinic receives the user's vaccination request, automatically validates the input, and performs an additional identity check. Verifiers can perform this additional authentication step by checking a traditional paper-based identification document, such as a driver's license, or an IDAS-conformant digital signature. Courtesy of an iris scanner supplied by iRespond, the implementation also demonstrates the use of a biometric ID as an authentic root of trust. With all information available and verified, a clinician performs the vaccination and creates a verifiable credential. In this implementation, the personal data store of the user and the semantic container of the vaccination clinic store the vaccination request and verifiable credential. These locations house machine-readable usage policies to dictate data usage terms, secured cryptographically. For the second data flow, we demonstrate the verification of a credential at a checkpoint. The user initiates the process by scanning a QR code supplied by the checkpoint. The user receives a request to provide evidence of vaccination status and the usage policies that describe data handling at the checkpoint. If acceptable to the user, and with a compliant verifiable credential available, the user submits a verifiable presentation. The officer performs an identity check, either paper-based, via a digital signature, or through a biometric ID. The validity of the verifiable presentation is assessed and automatically documented. The officer makes a final decision to admit or decline entry, and the user receives a dedicated verifiable credential documenting the process. According to agreed-upon usage policies, both the user and checkpoint have contained access to the data exchange audit trail, all cryptographically secured. We demonstrate secure and traceable data sharing between an individual and an organization in the third data flow. On the organization side, the infrastructure utilizes a semantic container to store a survey and an associated usage policy and a participant list. Each participant receives an email containing a link to access a data sharing plugin for the personal data store, where they can review detailed information regarding the survey. Each user then fills out the survey and selects some accompanying data. When the data is shared, a unique digital watermark enables unambiguous identification throughout the data lifecycle. The organization manages all survey responses in the semantic container and can automatically process GDPR information requests or requests from the user to revoke previous consent instances.